In this video, I will walk you through free response question number 5 from AP Calculus Practice Exam 1. This problem is about differential equations. If you haven't seen problems 1 through 4 yet, you should probably watch those first. Either click the link that appears in the upper right-hand corner, or find the link in the description. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams, at time t days after it is first weighed, then dB dt is equal to 1/5 times 100 minus b. Let y equals b of t be the solution to the differential equation above with initial condition b at 0 equals 20. Part A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. The function dB dt gives the rate at which the bird gains weight as a function of current weight b. To find out how fast the bird is gaining weight when it weighs 40 grams, all we have to do is evaluate dB dt at b equals 40. This turns out to be 12 grams per day. To find out how fast the bird is growing when it weighs 70 grams, all we have to do is evaluate dB dt at b equals 70. This turns out to be 6 grams per day. In summary, the bird is gaining weight faster when it weighs 40 grams because dB dt at b equals 40 is greater than dB dt at b equals 70. Part B. Find the second derivative of b in terms of b. Use the second derivative to explain why the graph of b cannot resemble the following graph. To find the second derivative, we will take the derivative of the first derivative. I see the 1/5 in the front, which I will simply bring down. Then I move on to take the derivative of what's inside. But the derivative of 100 is 0, so I write nothing. Next we run into a minus sign, which is another constant that I just bring down. Finally, the derivative of b is dB dt. Let's move this negative sign out to the front. So now we have this, but dB dt is equal to this expression. So let's make that substitution. So now we have this. We can simplify this a little bit by multiplying negative 1/5 times negative 1/5. So here is our expression for the second derivative. Notice that this factor will be positive for values of b less than 100, but b represents the weight of the baby bird. 100 is the adult weight of the bird. So the baby bird weight will always be less than the weight of the adult bird. Therefore, this factor will always be positive. Of course, negative 1/25 is always going to be negative. Therefore, the overall value of the second derivative is always going to be negative. A negative times a positive. This tells us that the graph of b is concave down during the days when the weight of the baby bird is less than 100 grams. The graph of b cannot resemble the given graph because it is concave up during the first days of the bird's life. Part C. Use separation of variables to find y equals b of t, the particular solution to the differential equation with the initial condition b at 0 equals 20. To solve this differential equation, let's get all of the b's on the left and all of the t's on the right. We begin by moving the dt over here by multiplying both sides of the equation by dt. We cannot separate variables by addition and subtraction, so do not distribute the 1/5. Instead, let's move the 100 minus b over to the left by dividing both sides by 100 minus b. Now that we have the b's on the left and the t's on the right, we can integrate both sides of the equation. Do not integrate without actually showing this integral sign. We can integrate the left side using a mental u substitution. Let's imagine that u is 100 minus b, and in that case, u prime is going to equal negative 1. This is all in your head. You don't need to write this down. So we think of this as 1 over u, and we know that the antiderivative of 1 over u is the natural log of the absolute value of u plus c, but we will save the plus c for the other side of the equation. But not so fast. Instead of db, we think of this as du over u prime, but u prime is -1, which will end up out in the front. Of course, the antiderivative of 1/5 will become 1/5 t. And now we will introduce the plus c. Let's use this initial condition to find the value of c. When t is equal to 0, b is 20. So now we have this. This means that c is equal to negative natural log of 80. Let's substitute this back in for c to complete the equation. So now we have this. Remember that b is the weight of the baby bird, and 100 is the weight of an adult bird. So b will always be less than 100. This expression will always be positive, and we can drop the absolute value symbols. This is a solution to the differential equation. However, we need to find the solution in the form y equals b of t. That means we need to solve for b, get b by itself. Before we get started, let's get rid of this negative sign by multiplying both sides of the equation by -1. So now we have this. I am going to reverse these two terms for aesthetic reasons. This just looks a little bit neater to me. To get rid of the natural log, I am going to exponentiate both sides of the equation. In other words, I'm going to drop a base e on both sides. The base e and natural log are inverse functions which cancel each other out. So I'm going to end up with 100 minus b is equal to, I'm going to rewrite this a little bit. I can't cancel out the base e and the natural log because I have this extra factor being subtracted over here. So I'm going to use a property that works this way. If I have e to the a plus b power, that's the same as e to the a times e to the b, a little property of exponents. So that's why I can rewrite this as e to the natural log 80 times e to the -1/5 t. Now I can cancel out the base e and the natural log, leaving behind 80 in the front. So I have 80 times e to the -1/5 t. Adding b to both sides of the equation and subtracting this term from both sides, we have this. I'm just going to flip this around. So b equals 100 minus 80 times e to the -1/5 t power.